Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad and I will present about our artificial intelligence design for Battlesnake. Our group name is Metallica. Hidup ni keras, man. So for the next slide, we will talk about our team member. The first team member is Muhammad ZHARIF Haikal, myself, Muhammad ABID, Muhammad Faris Haikal, and Muhammad Amirul Arifin. So for the challenge one, we will talk about the Battlesnake Ai, which is performance environment generated in sensor. For the performance of the Battlesnake, we will include the food consumed, survival time, and snake eliminate. For the environment of the Battlesnake, which is the game board, location, and obstacle. Actuator of the Battlesnake is snake body movement. And the sensor for the Battlesnake is position of the snake and the size of the body. So this is the step by step to create the Battlesnake. First, we will need a replic account and insert the code from the GitHub. And next, we will need to create the Battlesnake account and pass the URL link to the Battlesnake from the replic, and then we can create the game and add the Battlesnake to the game. So for the solution step, the PS of the Battlesnake is served as a fundamental design and evaluation structure, providing a systematic approach for the game. Performance measure based on food consumed, survival time, and eliminating on the snake. Environment is measured through game board, food location, and obstacles. Actuator is snake body movement, and the sensor consists of position of snake and size of the body. So for the challenge 2, we will move to our friend ZHARIF to explain about the challenge 2.
Okay, my name is Muhammad ZHARIF Haikal bin Muhammad KHAIRULZAMAN. Okay, for challenge 2, which is avoid hitting the wall. Here's the solution. The codes. By adding this sequence of codes, now the Battlesnake will be able to avoid walls. Solution step number 1, getting information about the walls. Okay, so here the code sequence. 2 variables, board width and board height, assigned values from the game state dictionary. The game state dictionary holds information about the current state of the game, including the width and height of the game board. This value represent the number of cells in the horizontal and vertical directions respectively. Okay, step number 2, preventing collisions with the left and right walls. Okay, so here are the code sequence. Okay, so my head X represents the X coordinate of the Battlesnake's head, and board width is the width of the game board. The board is 0 index, so the leftmost column has an X coordinate of 0 and the rightmost column has an X coordinate of board width. So if the Battlesnake's head is at the leftmost edge of the board, X coordinate is 0, it means moving left will result in a collision with the wall. Therefore, its move safe left is set to false to prevent the Battlesnake from attempting this move. Okay, similarly, if the Battlesnake's head is at the rightmost edge of the board, X coordinate is board width 1, moving right would lead to a collision with the wall. Thus, its move safe right is set to false. Okay, solution step number 3, preventing collisions with the top and bottom walls. Okay, so here the code sequence. Okay, my head Y represents the Y coordinate of the Battlesnake's head, and board height is the height of the game board. Again, the board is 0 index, so the topmost row has a Y coordinate of 0 and the bottommost row has a y coordinate of board height 1. If the Battlesnake head is at the topmost edge of the board, y coordinate is 0. It means moving up would result in a collision with the wall. Therefore, its move safe out is set to false. Similarly, if the Battlesnake's head is at the bottommost edge of the board, y coordinate is board height 1. Moving down would lead to a collision with the wall. Thus, its move safe down is set to false. Okay, for challenge number 4, which is avoid other Battlesnakes. So here are the code sequence. By adding this sequence of codes, now the Battlesnake will be able to avoid hitting other Battlesnakes. Okay, solution step number 1, getting information about opponent's snake. So here is the code sequence. This line retrieves the information about all the snakes present on the game board, except the snake controlled by your Battlesnake. The information is stored in the opponent's variable as a list of dictionary, with each dictionary represent a different snake. So here are the code sequence for solution step number 2, which is preventing collisions with opponent heads. For each opponent snake, this loop checks the position of its head and compares it with the position of your Battlesnake head, which is my head. If the positions match, it means the opponent's snake head is adjacent to your snake's head in one of the 4 cardinal directions, which are up, down, left, right. If an opponent's snake head is to the left of your snake's head, the move left is marked as unsafe by setting its move safe left to false. Similarly, the moves right, down and up are marked as unsafe if the opponent's snake head is on the right below or above your snake's head respectively. So here the next step, which is preventing collisions with opponent's bodies. Here are the code sequence. For each opponent's snake, this loop irritates over the segment of its body, excluding the head, and checks if any of these body segments are in the same position as your Battlesnake's head, which is my head. If a collision is detected, all moves left, right, down, up are marked as unsafe by setting their corresponding values in its move safe to false. So next step is identifying safe move. Here is the code sequence. These lines create a list called safe moves, containing only the moves or directions that are marked as safe in the is move safe dictionary. It filters out the unsafe moves and keep only the safe ones. The last one is last step is handling the case of no safe moves. Here is the code sequence. If there are no safe moves available, all moves are marked as unsafe due to potential collisions. The Battlesnake prints a message indicating this situation and chooses to move down as a fallback. This is done to ensure the Battlesnake makes some movement rather than getting stuck if it is in a tight spot with no safe moves.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Faris Haikal bin Muhammad HAFIZ, and today I would like to presenting challenge number 3, which is avoid hitting yourself. So the goal is to avoid hitting any body parts of the snake and stay alive. So this is the solution step. So the coding, first clarify that the coding is used to prevent collision with own body segment. So 4 segment in my body, which is number 1. If segment X, my head, which is my head, and my head is also clarified as Y, is to move to the safe, is to the left. Then is equals to the false. And then segment X, which is my head, X plus 1, and segment Y equals my head, which is Y, is moved to the right, it's also equals to false. This is repetitive as the coding shows on how the coding prevent the snake from hitting its own body. The move of the snake, which is up, down, and left and right, is to prevent collision with its own body segment. That's all from my part. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Faris Haikal and I am from group number 4. And today I would like to present about challenge number 5 for the Battlesnake project. So challenge number 5 is required to let the snake recognize the location of the food and try to move forward and keep the snake alive. So this is our solution step, which is the coding. So the first goal is to move forward to the nearest food. So let's say the closest food is located on the left side. The coding would ask the snake, which is my head X, will make the move to the left side, which is the safe part. And then let's say the closest food, which is X, and then the safe move is located on the right side. The coding will ask the head and the snake to move to the right side. And then same goes to the closest food, which is Y. If the safe move is located on the downside, then the next move will be on the down. And next, finally, if the closest food is located on up side, the safe move would make the snake to move to the up. And then if no safe move toward food, the snake will choose a random safe move. So the coding next move equals to random choice, as long as it a safe move. And then next, finally, if the no food available, it also will choose a random safe move. So the coding is next move equals to random choice as long as it is a safe move. That's all for my part. Thank you.
So for the simulation result, we can create the game and add our bot Battlesnake to the bot, and we press the play button, and the snake will move according to our code. So this game includes the health bar here and the reaction of the bot to the food. From the game, the record of the movement will be recorded in the web view here. As you can see, all the record moves will display in the console.
We'll continue with the milestone of the project. First, we received the instruction on week 11, and then for the week 12, challenge 1 is completed, and then week 13, challenge number 2 and number 3 is completed. For challenge number 4 and number 5 is completed by week number 14, and finally Battlesnake AI project submission is on week 15. That's all from my part. Thank you.
For the conclusion, our Battlesnake AI has been enhanced with the PS framework, enabling it to evaluate its performance, navigate the environment, and strategically avoid collision. With more development of the Battlesnake through test and error, the snake will be able to move more accurately and completing the task. So that's all from our team. Thank you.